In continuation to earlier lecture, I already mentioned you to construct a PDA. We have to decide three things. The first one is when we have to do the push, when we have to perform the pop operation, and when we have to change the state. For example, here we have a to the power of n, b to the power of n. For this one, what we are doing is we are changing the state whenever we have a first occurrence of b. You got my point? For initially we are dealing with the q naught for entire a's that we pass through. You got my point? A z naught, A z naught. You got my point? Here A is the input symbol, z naught is the top of the stack symbol, and it should be A z naught, and that means top of the stack is A. You got my point? Top of the stack is A. This is the first time that we encounter A for the corresponding q naught. For every other time that we encounter A, that means that the top of the stack symbol is A, the input symbol is A. After that one A, that means we have another A that is pushed onto the stack. For all other A's, we have this this transition will be done. You got my point? Whenever we have an occurrence of B, that means we are going to change the operation. What we are doing is now is push operation. We are changing the operation. In generally, whenever we are changing the operation, then generally we will change the state. You got my point? First we will do push operation. After that one, we have a pop operation. First pop operation, where we are going to encounter the first B, first input symbol B, first pop operation. Then we are going to change the state. That means whatever in the corresponding next state, that means there should be no A at all. There should be no input symbol A at all. Only B's. That means only pop operation. Push, pop. The first pop operation has some change of state. You got my point? For we are doing for final state acceptancy. For that is why we have this transition. This is common to almost all PDAs that you come across. You got my point? You can see that here the epsilon means end of the string. End of the string. Generally, if everything is right, everything is, the corresponding input string is accepted, there should be a epsilon at end, there should be a z naught on the stack. Then that means the corresponding we are transitioning to new state q2, which is nothing but a accepted state. Double circuit. You got the point? This is for a to the power of n, b to the power of n. What we have to do is we have to go for a logic when we have to perform push, when we have to perform pop, when we have to change the state. These are the main three things that we have to keep in mind to build the PDA. For example, the next example is WC, W to the power of R. C is a character and W is belongs to corresponding AB whole star, any string, and W to the power of R means reverse of it. Reverse of it. You got my point? What we do over here that until we encounter C, we do push operation. We do push operation. After C, we do pop operation. We do pop operation. You got my point? And moreover, it is in reverse order. WC, W to the power of R means whatever the stack data structure we have principle called last in first out or first in last out. That means the contents that we push onto the stack, and whenever we are going to pop from the stack, we will have in reverse order. That is why this example is very easy for us to construct a PDA. Whenever we have W, we are going to push. After C, for C we do nothing, and W to the power of R we are going to pop. You got my point? This is the logic over here. For initial, there may be a, there may be a B. Input symbol A or input symbol B. For that one, a push operation. You got my point. For every other A, for every other B, we are going to push. You got my point. We are going to push. There may be a situation where we have A input symbol and top of the stack symbol is B, where we are going to push onto the A. Same way for B, BA. In this way, we are going to grow the stack. Only push operation. You got my point. For entire this W. Whenever we have C, we are going to change the state. We are going to change the state. Generally, we will change the state whenever we are changing the operation. That means we are going to change the operation from push to pop. That is why we are changing the state. Remember that changing the state is relevant to the corresponding operation. We are going to change the state whenever we are going to change the operation. In general. You got my point. And here it is for every W to the power of R, we have pop operation. You got my point. This is the thing. To write all these things, take a simple string over there. Actually, we do first these sequence of parsing the corresponding input string. After parsing this only, we are able to write all these transitions. You got my point. You cannot directly write the corresponding transitions without parsing a string, without processing a string. You got my point. First, what you have to do is you have to write this, and after that one you have to draw this entire PDA. After that one, we have to define this 7 tuple value that we already discussed. You have to define this 7 tuple value, whatever the set of states, sigma, tau, delta, and various transition functions for the constructed PDA, and the corresponding Q0, Z0, and F. What are the different final states for the corresponding PDA that is constructed? Here it is Q2, here it is Q2, here it is a Q2, generally here it is Q1, like that. You got my point. You have to mention all those things. After constructing PDA, you have to mention the 7 tuple value in the exam. You got my point. To get the full marks, you have to define the 7 tuple value. Remember that one. What we have to do is to construct a PDA. First you have to process a string. After you have to construct a PDA. After you have to define the 7 tuple value of the PDA. Formal representation of PDA. You can see that for A, Z0, we are going to push. Up to C, we are going to push. After C, actually for C we do nothing. After C, we will start the pop operation. We are changing the state here. And after that one, we are going to pop. For B, B epsilon. For A epsilon. Very, very important point over here is we have reverse. That means whatever the push operations that we have done, we have reverse over there. The same way for B, there should be a top of the stack is B. For A, for input symbol A, the top of the stack symbol should be A. Then only that means the string is accepted. If any B top of the stack is A, that means that is not accepted. That is why that transition is not mentioned over here. That means whenever that happens over here, it is stuck in the Q1 rather than Q2. You got my point? Which is not Q1 is not final state. It is stuck over here. You got my point? Only these two transitions will be there so that the entire valid string can be processed. You got my point? In this way, the final state acceptancy epsilon Z0 accept. You got my point? Generally, we have two types of push down automata. One is deterministic push down automata and the next one is non-deterministic push down automata. In deterministic push down automata, we know when we are changing the state and all those things. We have particular transition that is mentioned over there. Actually, we are transitioning from one state to another state by consuming an input symbol. But in non-deterministic push down automata, we have a situation where we won't consume any input symbol, but we change the state. That is nothing but non-deterministic push down automata. For earlier example, we have WC W to the power of R, where C is the deterministic way of representing when the reverse of the string is started. You got my point. After that one, after C we have reverse of the string is starting. You got my point. A B C. After that one we have B A. You got my point. But here we don't have any C over there. We have to guess that the next reverse of the string. You got my point. That is why it is non-deterministic. That is why we have same way we have whatever the C we have, we guess on some input symbol, epsilon, and we do nothing over here. The same way that we deal with the C. You got my point. We are going to push over here and we are going to pop over here. The only matter over here is that we won't consume any input symbol while transition from Q0 to Q1. Same way for the input symbol, we have another transition called epsilon Z0 Z0. You got my point. These are the addition. You got my point. For W to the power of R. And the next example is equal number of A's and equal number of B's. Earlier we have A to the power of N, B to the power of N. That means all A's are over. Then only we have starting of B's. Here we have equal number of A's and equal number of B's. That means A's can be anywhere, B's can be anywhere. You got my point. You can see some examples out there. Possible strings. I'm taking a valid string and I'm doing. Actually, what I'm doing is simply for A, push A, for B, push B. Whenever we have reverse of it, that means input symbol is A and top of the stack is B. You got my point? Then we will pop. Same way for the input symbol B, the top of the stack is A, then we will pop. These are the two push operations and these are the two pop operations. You got my point? In that way, we are going to balance the number of A's and number of B's. You got my point? The logic is very simple. Whenever we have A initially and top of the stack is A, we will push. Whenever we have B and top of the stack is B, we push. The initially for Z0 we will generally push. You got my point? For any other operation, that means we have top of the stack is A and the corresponding top of the stack is B. That means corresponding A we have corresponding B. That is nothing but equal number of A's and B's. We are going to pop. We are going to pop for B. You got my point? Whenever there is the situation epsilon Z0, that is nothing but accept. You got my point? Simple way of for representing equal number of A's and B's. You got my point? Same way for A to the power of N and B to the power of 2N. Here the logic is we push 2 A's for every A that we encounter and we pop B for whatever the B that we encounter. You got my point? For every A input symbol we push 2 A's. For every A we push 2 A's. You got my point? For B we are going to change the state because we are changing the operation. Push to pop. Here we are popping the corresponding thing and this is the final state acceptance. Same way for A to the power of N, B to the power of N plus M and A to the power of M. For A to the power of N, B to the power of N, push pop. You got my point? The logic. Same way we have A to the power of N, A to the power of N. We do nothing over here. Push pop. These are the some of the logics that I already explained. You do submit all those things. Thank you.